The periodic table is a fundamental tool in science. It organizes all the known chemical elements. These elements are the building blocks of everything around us. The table arranges the elements in a specific way. This arrangement helps us understand their properties and how they interact. The periodic table is like a giant puzzle board. Each element is a piece of the puzzle. When we put the pieces together correctly, we see the bigger picture. We can predict how new elements might behave. We can also understand how elements combine to form the world around us. The periodic table is essential for students, scientists, and anyone curious about the universe. It helps us make sense of the vast diversity of matter. It also allows us to predict and explain chemical reactions. The periodic table is structured in rows and columns. These rows and columns have specific meanings. The rows are called periods. The columns are called groups. Each period represents an energy level. Elements in the same period have the same number of electron shells. These shells are regions around the atom's nucleus where electrons are found. As we move down the periods, the number of electron shells increases. Each group represents elements with similar chemical properties. Elements in the same group have the same number of valence electrons. These are the electrons in the outermost shell. Valence electrons determine how an element interacts with other elements. The periodic table also has blocks. These blocks are based on the type of orbital being filled by the last electron. The S block includes alkali metals and alkaline earth metals. The P block contains a variety of elements, including halogens and noble gases. The D block consists of transition metals. The F block includes lanthanides and actinides. The periodic table categorizes elements into three main types: metals, nonmetals, and metalloids. Each type has unique characteristics and properties. Metals are typically shiny, malleable, and ductile. They are good conductors of heat and electricity. Most elements on the periodic table are metals. Examples include iron, copper, and gold. Nonmetals are generally dull, brittle, and poor conductors of heat and electricity. They are located on the right side of the periodic table. Examples include oxygen, nitrogen, and chlorine. Metalloids have properties of both metals and nonmetals. They are often semiconductors. This means they can conduct electricity under certain conditions. Silicon and germanium are examples of metalloids. They are used extensively in the electronics industry. The periodic table is a cornerstone of modern science. It has numerous applications in various fields. The periodic table helps us understand the chemical behavior of elements. We can predict how elements will react with each other based on their positions on the table. This knowledge is crucial in chemistry, materials, science, and other fields. The periodic table has led to the discovery of the new elements. By observing trends and patterns, scientists have predicted the existence of elements before they were actually found. This predictive power is a testament to the table's elegance and utility. The periodic table is essential in various technologies. For example, silicon from the metalloid category is crucial in computer chips and solar cells. Rare earth elements, found in the F block, are used in magnets, lasers, and other advanced technologies.